Hello everyone. Okay, let's look at the next example. Now let's choose the problem 8.35 at page 418, and again in this case we'll deal with the magnetic boundary conditions, whereby we have a circular cylinder. So if you can see from the questions, we are given a cylindrical structure whereby the first region defined inside the circular cylinder. So these are our first regions, and then the second region defined outside or the exterior of the cylinder, which is here our second region, which belong to the free space region, and we have the mu2 will surely equal to mu naught. Then we have the mu1 for the case of inside the circular cylinder. It has the value of mu1 is equal to the 800 mu naught. Okay guys, now we are going to look at these two regions whereby they are splitted at this boundary at certain r value, isn't it? We don't know yet the value of radius. So we know that these two regions is splitted at the R boundary, right? So if you can see from the questions, we are given the value of B1 that appear inside the circular cylinder. The B1 guys here is given as mu naught. Here we have 22 R component plus 45 phi component Tesla. Okay guys, so if we can extend or expand the equation, we're gonna have here 22 mu naught R component plus 45 mu naught phi component. Okay guys, so since we know that the region actually is splitted at the boundary at r equal to something, or let's say at r equal to r naught. That's our assumptions. So by right, we know that guys, the normal component of this B1 actually belongs and has this value, right? So here actually belongs to our B1 normal component. Why? Because the two regions here is splitted at this boundary at certain r value, isn't it? So by right, we know that this r component actually belongs to the normal component of B1 vector, and the rest here belongs to the B1 tangential component. Okay guys, alright, so now we are going to determine the B2 outside the cylinder, whereby the B2 which actually exists in free space regions. So again, to find the B2 we know that is composed of again two main components, B2 normal plus B2 tangential, and then to find the normal component we can simply use our first magnetic boundary conditions equations, which can be expressed as here. The B2n is equal to the B1n. So this one we have obtained earlier, or we defined earlier from here. So B2n will equal directly to this value, which is equal to 22 mu naught R component. Alright guys, that's our B2 normal component. Again, since the question doesn't not mentioning anything about surface current density that appear on the boundary, on the interface, so at this boundary, right, the whole interface, we assume that there is no surface current density appear. We assume ourselves. So again, to use tangential component equations to find the B2t, we have to assume there is no surface current density appear at the interface. So from the original equation, we have here H1t minus H2t equal to Js, and Js here we assume 0. So again equal to 0. Now we have here H1t is equal to the H2t. Alright, so now to find the B2t, just convert this H into B term. The H1t is equal to the B1 tangential over mu1, and H2t also is equal to the B2 tangential over mu2. Now our B2t is our target now. So let's take out the B2t. The B2t here is equal to the mu2 over mu1 times B1t. So since we can since there's no GS right here, so you can simply also put the vector as shown here, because there's no GS there, so we can simply put a vector, right? Again, let's substitute the mu1 and mu2. The mu1 is equal to 800 mu naught, and the mu2 is equal to the mu naught because of free space. So now we can have here mu naught over 800 mu naught, and B1t is obtained earlier, which is 45 mu naught phi component. Okay guys, so if we proceed to the end, we can find the B2 tangential, which equal to the 0.05625 phi component mu naught. Okay guys, so to find the complete expressions of B2, we just combine between B2n as obtained earlier and this B210, this B2t. So now we have here the B2 is equal to factorize the mu naught. Now we have is 22 R component plus 0.05625 phi component a unit of Tesla. Okay guys, so this is our final expressions of B2, which exists outside of the cylinder in the free space regions. Alright, so guys, I hope you can try yourself, and all the best for your study. Thank you.